In this issue of Spacecraft Guide, we have a special for you. Not only are we going to teach you how to fly the space shuttle, focusing on the primary flight display here, but we're also going to do something special for the 55th anniversary of Apollo 13 for our paying subscribers. So if you're paying subscribers this week, we're going to do something special for you. But let's start with learning how to fly the space shuttle, and we're going to do something special. We're going to do the velocity indicator, and if we click on the primary flight, it takes you to the primary flight display page, and here we have the primary flight display. Right now we're going to be working on this instrument right here called the altitude rate scale, and when we click on it, it takes us to the altitude rate scale page. And as we can see, this is called the altitude rate, also called the H dot, or because it's a altitude velocity, or a height velocity, which is for the 8, and it's the first derivative for all of you calculus geeks. And this displays the vehicle altitude rate, which is read at the intersection of the moving tape and the lubber line. The scale is from 2,940 minus to plus 2,940 feet per second, with the scale changes at 170 feet per second and positive 700 feet per second. The negative and positive regions are color reversed. Negative numbers are white on a black background, and positive numbers are black on a white background. So if we have any aviation buffs out there, this is basically your vertical speed. So usually in an airplane, 500, 1,000 feet per second, 1,500 feet per minute. Feet per minute in an airplane. We're talking feet per second is what this is in. So this is a much faster, and of course you're accelerating. Your velocity is going to be extremely fast as you're trying to get to 17,500 feet of 17,500 miles per hour. So that's why this is such a very fast rate for this tape here. Now we go a little bit deeper into it. In general, we see here the altitude and vertical velocity indicators. So all these indicators that you can see that are specifically on the right side. You see here we have the altitude rate scale displays as altitude rate, or which is right on the intersection as we see. But up here they also have altitude acceleration, which is the next derivative. So we're going from a rate to an acceleration here. We're going to go over that next week, but that's the difference. And then we have the altitude scale, which is the height that you're over. So this is static. This is you're moving at a specific rate, like say you're going 55 miles an hour. That is a rate. And then there's one more, which is acceleration, and that's going, say, from going from 0 to 60 in 5 seconds. That is your acceleration, and that will create the G's. So that is what that instrument is measuring. It's measuring the rate at how fast you are going into outer space, and as a constant speed or a rate. Now, for our paying subscribers and our free subscribers, we're going to go a little bit more in depth into the schematics. And if you are a free subscriber, and I have a special for you, if you sign up today, you're a free subscriber, I have a free chapter of my book on the familiarization manual of the Apollo spacecraft that the astronauts actually use. I have the chapter on docking and transition, which is pretty, that's something that goes on topic with Apollo 13 because they are having to keep both the lunar module and the command module connected and use the lunar module for something that it wasn't supposed to do, and while they were docked and transferring. So if you are a free subscriber, or if you sign up for free now, you can get that free chapter of my book of the manual that the pilot or the astronauts used to learn about the Apollo spacecraft. And if you click on schematic, it takes you to the dedicated display and control schematic as we see here. So we have our computers and our driver display, and that's going to come down here as we can see into our indicators. But right here we have the vertical velocity indicator. So right here in the display driver unit, that is where this gauge lives and works, and it displays that vertical velocity as we've seen. And that information it also goes over the vertical velocity, goes into the HUD here, although we don't see a line that goes into it. But the HUD also has that vertical speed, vertical velocity, and also vertical acceleration. So this in the schematic is where that instrument lives. Now, for our paying subscribers, and that is again $4 a month. That's going to change here shortly, but for $4 a month, we're going to go into how the vertical velocity indicator and how that is related to Apollo 13. So if you are a paying subscribers, and again I thank you,